Hey everybody, Miss Martello here. So after I did my angles of rotation, the next thing that I wanted to look at is the reflections that they're referring to. So they're talking about how a line, when it reflects onto itself, we call that a line of symmetry. So right now I wanted to look at the lines of symmetry on each of these figures. So when I start with the equilateral triangle, I definitely probably can tell this should be able to reflect onto itself over this line. And if you wanted to actually take your triangle and kind of fold it over to check, you could do that. But what hopefully you notice though is that that's not the only way you could fold it in half and have it line up onto itself. You figure if I turned my paper this way, it almost looks like the same thing. So had I been able to go down this way, that would have worked too. And say that I even flipped my paper around so that I was looking at it this way, same idea. I could go down and fold this way and I'd still be able to fold the triangle in half. So if I looked again, I had 1, 2, and 3 lines of symmetry on the equilateral triangle. So then I'm gonna write on there that I have 3 lines of symmetry. And then when I look at the square, kind of a similar idea, and we kind of talked about this a little bit with 6, 5. I could definitely go in half that way, but if I flipped it over or rotated around, I should realize that that way is going to work too. And for a square, I can also go this way and this way. And I kind of just like to kind of compare something that's kind of interesting. When I went from the triangle, it was like I went from the vertex to the middle of a side, vertex to a middle of a side, vertex to a middle of a side. But here I went vertex to vertex, vertex to vertex, and then middle of a side to middle of a side, middle of a side to middle of a side. So that's kind of something interesting that we might pay attention to as we keep going through. But the idea, those have 1, 2, 3, 4 lines of symmetry then on the square, which you already might notice is kind of funny. Triangle had 3, square had 4. But taking a look then at the regular pentagon, so hopefully you're able to see it again. If you need to fold, if you need to take your shape and kind of play around folding it, you definitely can. But a lot of us might realize the pentagon is going to be able to be folded in half that way. And then kind of like triangle, it might be easier to see if we kind of turn our figure this way is going to work too. If we kept folding it, then it would also be able to go in half this way. So that's a 3rd line of symmetry. If we rotated it again, this way, and one more time this way. So then if you go through and kind of count them, should have been 1, 2, 3, 4, and 5 lines of symmetry on that one for the pentagon. So again, 5 lines of symmetry. Funny, because pentagon has 5 sides. And I kind of noticed with that one, so it looks like it went again from the vertex to the middle of the side, vertex to middle of a 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 side, which was how the triangle went. So that's kind of funny. So pentagons, lines of symmetry were similar to triangles. Taking a look at the hexagon, when we go through that one, we should see on that one you could go like halfway this way. So that's vertex to vertex. It looks like we could do that again, and we could do that again. So there's 3. And if you were folding it, you might notice it that way too. But also though, if I went here, that would work. Cut it in half and I'd be able to reflect onto itself this way and this way too. And if you needed to turn your paper or your actual figure to see that, you definitely could. But so then that one had 1, 2, 3, 4, 5, and 6 lines of symmetry. So hexagon had 6 lines of symmetry. Funny again, because hexagon has 6 sides. And if I look back at those, so we had one that went middle of side to middle of side, another one middle side, middle side, middle, middle, but then we also had 3 lines of symmetry that went vertex to vertex. So that was like this one, and this one. So that's kind of like square, where we went middle to middle, middle to middle, and vertex, vertex. Interesting, because that was a figure that had 4 sides and this one had 6, whereas we saw this one that had 5 lines of symmetry was kind of like this one. Interesting. The octagon, when we look at the lines of symmetry for that one, you should be seeing here. And if you needed to kind of rotate it, you could, but also down the middle of those 2 sides, down the middle here. So there's a 3rd line and a 4th line. So all those went from the middle of each side to the middle of the side across from it. But then I also should be able to go from the vertices too. So from here to here should go in half. That's a 5th line. Here to here is a 6th line. And then I'm just going to turn it a little bit to see it easier. A 7th line, and then an 8th line. So octagon should have 8 lines of symmetry. And you might notice, again, they went from like the middle of a side, midpoint of a side to a midpoint on the 4 sides, and then also vertex to vertex, kind of like the hexagon or the square did. Even-sided figures. And then for the nonagon, this one's kind of interesting. This figure's got 9 sides, so you could almost probably guess how many lines of symmetry it already has. But kind of going and taking a look at it then, gotta make sure I arrange my camera right, should go from here to here. So from a vertex to a middle of a side. And again, vertex to a middle of a side should work. And then I'm just gonna kind of keep going around my figure. Vertex to a middle of a side, that's my 3rd line. A 4th line, 5th line, my 6th line, 7th line, 8th line, and then there's my 9th line. And it should be 9 lines of symmetry. And it should be that you're noticing for the nonagon that it goes from a vertex to the midpoint of the side across from it. Vertex to the midpoint of the side across from it. So that's kind of like the pentagon and the triangle. They all go from a vertex to the middle across from it. But the big thing that we definitely should be noticing as we kind of look back at all of them is if we have a regular polygon, the number of sides is going to be the same as the number of lines of symmetry. So like, for example, nonagon has 9 sides. It also has 9 lines of symmetry. Octagon had 8 sides. It also has 8 lines of symmetry. Hopefully that was helpful. Thanks for listening.